Hey YouTube, it's been a while. It's been a very busy summer here for me, so sorry I haven't posted more videos, but just been super busy. Anyway, today I'm in a 2005 BMW 325xi. This is the E46 chassis with the M54 engine, 2.5 liter inline six. So today's issue is we have a customer complaint of the transmission shifting kind of hard into each gear, coupled with a service engine soon light, as you can see here. Service engine soon light and the transmission warning indicator over here next to where the shifter indicator is. Anyway, he said that the symptoms happen whenever the check engine light is on. He's got a scan tool where every time he resets the ECM and transmission control module, check engine light goes away and the transmission shifts smoothly and normally, no longer shifting hard. But the other unfortunate thing with the code clearing is that the engine also runs really rough, stalling and such, up until the point where the service engine soon or the check engine light comes on. So I'm going to give it a scan here. I got my scan tool here. This one is a Think Car scan tool, and we'll focus mostly on the ECM and TCM fault codes right now. So that's what we're seeing. Misfire in pretty much all the cylinders. The fuel trim for both banks 1 and 2 is exceeded beyond the permissible range, and we have a plausibility error for the air mass sensor or mass airflow sensor. And for the TCM, we see a can torque interface. It's kind of a generic code, generally tied into this mass airflow sensor code. I believe the TCMs on here use the mass airflow sensor as an input for determining shift pressures in the automatic transmission. So we'll go ahead and pull this thing into the shop. As of right now, it seems to be running on all 6 cylinders just fine, but we'll go ahead and pull it in the shop and see if we find anything with a visual inspection. So we are under the hood now, taking a look at anything relating to the mass airflow sensor. First thing I've noticed here is it's got an aftermarket mass airflow sensor. Not the greatest, but we won't condemn it just yet. One thing to check on these cars, especially now that they're older, is to make sure that these intake boots are intact. If we have a tear in here, that will cause the mass airflow sensor to read incorrectly. You'll have an unmetered air leak. So we just take a good peek here and just make sure that everything on this hose is fine. And I've already spotted something. I can just get the light to cooperate. If you focus in right here, you can see that we have a substantial tear right at the tip of my finger there. There's a substantial tear on the intake boot here. So that's definitely a problem. We'll go ahead and pull the air filter box off and inspect the underside of this hose, but I suspect that we'll probably end up having to replace the whole thing. All right, so I've went ahead and gotten the air filter box unclipped so that I can take a look at the underside of this intake boot. And as you can see, hopefully, we've got a very large tear here. So not only was that first tear a bad tear, this is a pretty bad tear also. So I'm going to go ahead and get this intake boot ordered. I don't really want to get into the other codes just yet until we know that this intake boot is intact. So to get this boot off, it's a relatively simple job. It's just a matter of removing everything that's in the way. So let's start off with removing the mass airflow sensor connection here and take that off. There's several hose clamps that we'll need to take care of. So try to pull those off. There's this vacuum hose here connection that we'll need to pull off. Pretty much start pulling everything off. So as you can see here, I've got the top half of the air filter lid off. I've disconnected this elbow from the boot. We got a couple more clamps down here to take care of. You can either use a flathead or a 6mm socket if this car has original clamps, which it appears that it does. So just a matter of getting everything out of the way. We may have to remove the DISA valve off of the intake manifold to get to the other hose clamps here. So to remove the DISA valves, fairly easy. You need a Torx socket to get to a bolt right here and another bolt right here. There's an electrical connector here that needs to come off, which there's a clip there that you can push in. Let's see if I can do it on camera. Push it in and then pull it off. So you push on this and then pull it off, which gets you some more space to this Torx bit or Torx screw. Remove those two and the DISA valve should come off. So I've gone ahead and removed the two Torx screws here, T40. This should just pull straight out of the intake manifold, like so. I'm gonna use my other hand so I can get it out of here, and that should give us better access to the intake boot. Be sure to check it. These are known to fail. If you have this flap here that becomes loose, that could mean some trouble. So good time to replace your DISA valve. But as you can see here, we have better access to the hose clamp now. So we can get that one off and hopefully get the driver in there to remove the other one. Okay, so as you can see here, I've got the smaller hose which goes into the idle air control valve. Got that removed, and that gives us access to, so that will need to be removed. And that should be all we need to remove this boot from the intake manifold. Also, we just want to be mindful to not let anything fall into the intake manifold. We don't want any foreign objects in there because that could be disastrous to the engine. So if you are uncomfortable with having a gaping hole like that, please tape it up or do something so that we can prevent anything from getting into the intake manifold via this hole or this one. So this is a very handy tool to have. It's a flexible shaft, 1/4-inch drive nut driver basically. So we can get around the corner there to loosen this clamp. So we'll give it a few turns. And now this should just pop off. All right, there we go. So that's more details about how this is in there. So there's the piece that goes to the throttle body, and this is the piece that goes to the airbox. A good idea to replace them in pairs. Usually if one starts to rot out, the other's not far. As you can see here, there's yet more cracking. So I went ahead and ordered a kit from FCP Euro, which has all BMW factory parts. I'll have the part numbers listed in the video description, as I don't have the paperwork here. But it comes with the upper and lower intake boots, has this connector that connects the two pieces together, all the hose clamps, and this elbow connector. It's a nice little kit in case you need to replace any of this stuff. The clamps on this car were okay, but since I have them, I'll go ahead and use the new clamps. All right, so I started preparing the new hoses, just set them up like the original. So I put that coupling here, put the 77 to 84 hose clamp here and tightened it, since I did not loosen that one on the original. Put the coupler in it, tightened the hose clamp. The other two 77 to 44 millimeter hose clamps go on the lower boot. The smallest hose clamp, of course, goes here. I will make mention of something. This tab right here actually lines up with a slot on the bottom. You can't really see it, but you can feel it. There's a slot on the bottom of the throttle body, pretty much at the 6 o'clock position that this tab lines up with. So I got everything pretty much set up. I'm going to get a little bit of silicone grease to put in these connections here just to make it a little bit easier to get everything lined up. And I've oriented the hose clamps the same as it was from the factory. Okay, so I've got the lower boot installed roughly. This is just a silicone grease I like to use. It doesn't have to be the Motorcraft stuff, just any sort of rubber compatible silicone grease works just fine. So what I did is I placed this onto the throttle body. I'll use this as an example. So I was able to feel on the bottom of the throttle body, and what I did is I pushed this onto the throttle body, and this tab, I just rotated it until the tab lined up with the grooves in the bottom of the throttle body, 6 o'clock position. And once that's aligned, unfortunately, I cannot show this on video. It's impossible. There's just no view. But you'll have to feel for it. There is a groove there that it lines up with. Just feel it, use your fingers, rotate this gently. That grease helps a lot. As I tighten that hose clamp, I also made sure that the hose clamp was sitting in its groove properly. So in the groove here in the rubber, I'll just show you in the original. So this groove right here, you want to make sure the hose clamp's in that groove properly. After you tighten it, you don't want it all cockeyed like this. You want it in the groove. So once that's tightened down, you can go ahead and put the hose piece onto the idle air control valve. Of course, I can't do this with the camera in my face, maybe. But, oh, here we go. So, got it in there. Go ahead and spin the clamp around and use my flex head nut driver. Okay, so we have the hose clamp for the IAC valve here tightened all the way sufficiently. Now I'm going to elect to put the upper hose on, and that just snaps into place here using this coupler, and we'll go ahead and tighten the hose clamp there. Okay, so I've got that snug down, not tight all the way, so I can still rotate this as necessary to match up with the lid of the airbox. We'll go ahead and put the DISA valve on at this point using the two T40 screws and the electrical connector for the DISA valve. The DISA valve has been installed using the two screws that we pulled out originally. The electrical connector is plugged back in on top here, as you can see. I'll have the torque specs on the video description, but these go into the plastic intake manifold. They don't need to be in there that tight, just snug. That's all you need to do. So finally, we've got this elbow here. This elbow is in good shape. This hose is in good shape, so I'm not going to disrupt that. I will give the customer the replacement one to put in the glove box just for a rainy day. I'll go ahead and put a little bit of silicone lube on that to make it a little easier to push in. And we'll put the air filter in and mount the air filter box in. Again, we'll put a little bit of silicone lube to help that. So we've got the air box lid latched back into place. So there's latch there, latch here, one down here, right there, tip of my finger, and one more that's a little bit difficult to get to right there. Got the air box latch down, this air intake connector here connected back up. Now we'll just get this lined up and put into place here over the mass airflow sensor, and get the mass airflow sensor plugged back in. Ensure that all of the hose clamps, like that other one down here that I haven't tightened all the way, make sure that's all tight. All right, so we'll just do one last check, make sure the air box is all connected in there, snapped into place with the snap fit connectors there. The mass airflow sensor is connected. Hose clamps, every single hose clamp that I touched is tightened. Connector for the DISA valve is in place. This elbow for these vacuum lines are in place and everything is back to how it was before I took it apart, or in this case, in better shape because we've got the new intake plumbing in. So we'll go ahead and reset the codes for the ECM and TCM, give this thing a test drive, see if the symptoms come back. There could still be more going on with this car. So it has been 24 hours since we reset the codes on the vehicle. And on the first start of the morning, we ended up having a service engine soon light. The vehicle is still driving very nicely. The transmission is no longer going into limp home mode, and the engine's smooth, has plenty of power, but this light is on. So we'll have to plug the scan tool in and see what codes are showing up to see if any of them are the same or if they've changed a little bit. So got the diagnostic trouble codes here. As you can see, we've got 2 codes. This is for the flow rate for the secondary air system, affecting both banks. Secondary air system on these, the complaints are usually related to the air pump located in the engine compartment over by the passenger side headlight. What it does is it pumps air into the catalytic converter, usually when the engine is first started on a cold start. This air that goes in there helps warm up the catalytic converter so that the vehicle doesn't pollute as much when the engine is cold. So let's get the vehicle in the shop and proceed with troubleshooting. And the air pump in question is this guy right here, kind of behind the passenger side headlight and the washer bottle. So we'll go ahead and set you down here. What I'm going to do is I'm going to take the hose off here and the 3 mounting bolts that hold the unit to the body here so that we can access the electrical connector at the bottom. Okay, try not to lose any of the screws. So it pretty much lifts off the bracket as follows. And you'll see a big electrical connector here. Just push on the release clips on the sides, and the plug should just come out. So the next thing we're gonna do is we're gonna get a test light on these 2 pins here. The brown's ground and the black with red stripe is the power. All right, so we've got the scan tool ready to go. The ignition is on, key on, engine off. We're using my AES Wave test kit here. Has various different size leads so that you can plug into the connectors without worrying about spreading the terminals or wrecking the terminals. It's a very non-invasive way to do things. I've got my test light in a can here. This is basically just a headlight bulb with a connector. We can select the low beam, high beam, and of course the ground. We'll use the high beam circuit just to make sure that the circuit can actually handle a load. And we'll wire it up to the connector for the pump. So we'll go into actuation tests, general, and then relay secondary air pump. So what we can do here is we can hit active, the light should come on. And if the light comes on, that means that the engine management controller computer has control of this circuit. The circuit integrity is good. We can assume that the secondary air pump is faulty. So here we go. As you can see, very nice and bright. So we got good ground, we got a good power. We know that this circuit can handle a good load, which these pumps definitely draw a lot, at least as much as that high beam bulb would. All right, so something I'll mention is not all of us have scan tools, and not all of us have, fancy equipment to check things. So one thing you can do is you can just try to apply power directly to this guy. Simple DC circuit, positive, negative. It's a DC motor, so it doesn't really matter, you know, if you get the polarity right here, it'll just reverse the direction of the motor. So one thing you can do, just run a jumper to a 12-volt source. We'll go ahead and use the jump start location here. And in my case, I've got a power probe that we can use to turn power on to the device. Okay, so you can just make a set of jump leads, you know, with just normal wire. I have the test kit from AES Wave, so we'll go ahead and just put those on the terminals here. But just proof of concept, we know that the computer, or the engine management controller, has the ability to turn the circuit on. We'll just make sure that this motor is dead. I suspect that it is. So we'll apply the ground to one side of the connector, and we'll use the power probe. This has the ability to send a power or a ground, really, to the circuit here. So we'll go ahead and plug this in, and then give it some power and see if this fan turns on. And we have nothing. We're sending voltage. We have nothing, which is kind of what I suspected. All right, so the owner provided a non-OE or OEM part. This one came from Amazon, I believe. Easy enough part to get to. So if it fails, it's not a big deal. I guess this part was extremely inexpensive. So let's unbox it. And we'll do the same test that we did earlier with the original secondary air pump motor. Oops. So we'll go ahead and do this. All right, got the power probe set up again. Put ground to one side. And we'll see if this made in China blower pump, secondary air pump, that is, let's see if it does anything. So as you can see, it powers up. So let's continue on installing this guy. All right, so we've got both pumps here on the bench. We got the aftermarket Chinese one here and the Pureberg, which is the original equipment manufacturer for this. So we just need to swap the mounting bracket over to this aftermarket unit. This aftermarket unit came with the rubber isolators. So we'll go ahead and snug these on. Okay, so I'll probably just turn the camera back on once we get all of these on and snug down. Use a wrench to just put a little bit of torque on it. It doesn't take a whole lot. All right, so just a quick disclaimer. I actually had to use a tap on the captive nut in here, which is why I generally don't like to use these Chinese parts, but hey, it was cheap and it really didn't cost me a whole lot of time. So I got these isolators all installed and tightened with a wrench. So now we just need to move the bracket over and just make sure we orient the bracket the same way as it was on the original. BMW wasn't nice enough to give us access here to get this off with a socket. But that's okay, not a big deal in the grand scheme of things. All of these 10mm nuts, the head's 10mm, will orient the new one in the same fashion as the original. So when we swap the brackets over, we know we got it right. And just move on with tightening these nuts. These are rubber. You don't want to go overly tight or aggressive on them, just snug. Just snug. All right, so now that we've got the bracket installed, a lot of these aftermarket parts do not have the filter that's hidden under this cap. So we'll just double check real quick, see if, oh, okay. So this one's got a filter. A lot of the aftermarket ones I've seen do not. So if it does not, the unit that you pick up, if you decide to go with a Chinese one, swap it out from the original. In this case, we have it, so I'll just put the cap back on. It's just a snap fit connection, and we'll go back to the vehicle. All right, so we're back in the engine compartment. Something I will mention, here, let me zoom in a little bit, is it's a good idea to check this check valve for the secondary air pump. With the engine running, warmed up, you shouldn't have any exhaust coming out of this. If you do, then you might have an issue with the relay that controls the vacuum to this, or a problem with the check valve as well. One indication is when you pull the hose off, it'll have a lot of exhaust soot in it, which this one does not. I went ahead off camera and checked this valve. Was not able to feel any air go through this. Was not able to blow through this. You can use a vacuum pump here. Take this vacuum hose off, connect a little Mighty Vac vacuum pump, suck that down, and this valve should open, and you should be able to blow through this with vacuum applied to this spot here on the check valve. So the reason why I mention it is I've seen a lot of these check valves go bad, which allows exhaust to come back through and burn up the pump. So we've already verified that that's not the case here, so we can proceed with installing the secondary air pump. You all hate it when I say it, so I'm not gonna, well, I'll say it. It's reverse of removal. So go ahead and get the connector installed. Get this puppy oriented so that we can mount it up. Here we go. I'm just making sure that the wires aren't getting caught up on the exhaust or anything. And the 3 10mm bolts we'll put in here and get those snugged down. Careful not to drop them in the engine compartment. You're likely to not find them again if you do, which is pretty much the case with any of these German vehicles. Get this bolt lined up in this hole without dropping it in. Okay, perfect. I don't know what the torque spec is on this. It's just going into a bracket. Use your head. It's just these 10mm head bolts, which equates to an M6 bolt diameter. You just don't want to go stupidly tight on it. All right. Grab our tool. Lastly, we'll put the hose back on and tighten the hose clamp. And then we'll get the scan tool plugged back in and do a test. All right, so that's pretty much how you install the new secondary air pump. So let me get my scan tool plugged back in, connected to the vehicle, and we'll do a final test here before we clear the codes. All right, so we're back at the scan tool. We're gonna go back to the actuation menu, relay, secondary air pump. We'll go ahead and activate it and just make sure we hear that vacuum cleaner type sound that we typically hear when those turn on. All right, so we know that's working. We'll go ahead and clear the codes. I'll just show you the process on this scan tool. Clear fault codes. Okay, read fault codes. There are no codes. So we'll go ahead and drive this for a couple of days. So it's been about 4 days since the repair with the secondary air pump. Let the vehicle go back to the customer for a few days, and there's been about 170 miles put on the vehicle since then. Just doing this to make sure that we're not going to have any surprises with the check engine light. And we'll see here if the light is on. As you can see, the light is not on. So we'll go ahead and log into the scan tool here and see if the OBD2 IM drive cycles have been completed, or otherwise known as the readiness monitors. So we're here to the scan tool. There is no malfunction indicator lamp as we saw, and no DTCs. And as you can see here, there's 8 readiness completed and 0 not completed. So that means this vehicle went through all of its checks for the drive cycle. And we can go ahead and verify here to see what has been set and what hasn't. So as you can see here, everything has been set. The ones that I was most concerned about relating to the repair is the one that says secondary air injection monitor. That means the vehicle has run its test on the secondary air pump. It's happy with what it saw as far as its functionality is concerned. The other one was EVAP monitor. That one was not set as of when I let the vehicle go last time. But as you can see, all the ones that are supported for this vehicle are ready to go. So if we lived in an environment where there's an emissions test, it would pass the OBD2 portion of the emissions test. That's one thing that the emissions centers look for. But for those of us outside of emissions, this is a good way to know that we did the repair properly. So it was a little bit of a long road there, but we got the vehicle to the point where we're not going to have a service engine soon or check engine light come on as a surprise to the customer and myself. I'm convinced that the repair is complete and good to go. Anyway, I know this is a kind of a long-winded video. I decided to try a long format video for a change just to see how you all like it. If you like this video, please click the like button. And if you'd like to see more content like this, please leave a comment or and say, whether you like this or not, and I'll try to make more videos like this based on your responses. I hope you all have a wonderful day. We'll see you next time. Thanks.